Hi, welcome to Padai Planet, and we have got another question from circles, and this question is that a chord of a circle of radius 15 centimeters, right? That means the radius of the circle is given, and that is 15 centimeters. This chord is subtending an angle of 60 degree, right, at the center of the circle. So let's first draw what we have in this question, and suppose this is the center, and this is, I'm just trying to draw the sector, right? Now this is the chord, right? And suppose this chord is, let's name it as A, and this is B, and the center of the circle is this, and say this is named as O, right? Now what they're saying is that the radius of the circle is 15 centimeters. That means this is 15 centimeter and this is also 15 centimeter. The angle subtended at the center, this is 60 degree, right? Now what we need to do is we need to find the areas of the minor and the major segments. So first let's understand which is the minor segment, right? So this is the minor segment, this blue part, where all I am going to put these dots. This is the minor segment, which is created by the chord AB, right? Similarly, the major segment is this part, this entire thing, right? All of this. Right, so all of this. This is the major segment. Right. So I think it's clear now. So let's first identify the area of the minor segment. Now to find out the area of the minor segment, let's write the correlationship for that. So the area of the minor segment, that is equal to the area of the total sector which is created by this chord. So area of the sector, right? And this is the sector. Let me just highlight it with some other color. Yeah, I'll take it to this. So this is the sector OA, and this entire thing, right? And B, and from here this entire O. So this is the sector OA, right? And suppose this is in between, say this is P. So OAPB, this sector, the area of this sector minus the area of the triangle OAB, right? So once we get this, we can easily find out the area of the triangle, area of the minor segment. So let's first calculate these two things, right? The area of the sector of OAPB and area of triangle OAP. Now we are going to run short of the space, the screen space, so I'm going to use even this space. So let's solve it. The area of sector. Now the area of the sector, we already know that's theta upon 360 degree multiplied by pi r square, right? Now pi, they have already given us the value, which is 3.14, so we will put that 14 multiplied by the r square, that is 15 square. So we will write 15 whole square. Now let's expand it a bit more. So we will put the value of theta, that is 360. So 60 over 360 multiplied by 3.14 multiplied by 225. Right, so 6 times this, and this is 3 2s and 75, right? So this is what it is, and now we can write this as 1.57 multiplied by 75. So now let me take the help from my calculator. So that's like 1.57 multiplied by 75. So that's equal to 117.75. 117 square centimeter, right? Now that's the area of the sector OAPB, right? And now we are going to find out the area of the triangle OAB. Now to find out the area of the triangle OAB, let's do a small construction, and we will drop a perpendicular from point O to the chord here, and this is a perpendicular, so this is going to be 90 degree, right? And we already know that whenever there is a perpendicular which is dropped from the center to the chord, right, and if it is a perpendicular, then this perpendicular bisects the chord. So that means if this is x, right, if this is x, let me make it a little thicker. So if this point is x, that means AX is equal to AB, right? And these two triangles will also be congruent to each other, right? So because there are already three properties which are same, which is like OA is equal to OB because they both are the radius. OX is common between the two triangles, and AX is equal to BX. So which means that these two triangles are congruent to each other, and if that is the case, then that means these two angles, this angle and this angle, they both will be equal to each other, and that means each of them will be of 30 degree, right? So so far we have got this. Now we have to find out the area of this triangle. So that means we need to find out two important sides. We already know that the formula of the triangle, the area of the triangle. So let's write this. The area of the triangle OAB is equal to half into base into height, right? And base is AB, right? And height is OX. So AB multiplied by OX divided by 2. So what we need to do is we need to find out the values of AB and OX, and we can then easily find out the area of the triangle OAB, right? Now AB, if we look at this triangle OAX, right, let's look at this triangle OAX, then in triangle OAX we can already say that sine 30 degree is equal to AX upon OA, which means now sine 30 degree, we already know that the value of sine 30 degree is 1 over 2. So that means this is equal to AX upon OA, and OA is 15 here, right? So we can say that the value of AX is equal to 7.5 centimeter, right? So which means AB is 15 centimeters, right? Therefore AB is 15 centimeter, right? Because x is the midpoint of AB, so therefore AB would be 15 centimeters, the double of AX. Now let's consider the other triangle, and that's triangle OBX. Now here we will apply cos 30 degree, and that will be equal to, now that will be equal to OX upon OB, right? And with this we already know cos 30 degree, that is under root 3 upon 2, and that's like OX divided by 15, right? So here we can say that OX will be 7.5 root 3 centimeter, right? Now we've got these two things. We will put this in this formula, and we will get the area of the triangle. So AB, we already know it's 15. So this is like 15 multiplied by OX. OX is 7.5 root 3 divided by 2, and that's equal to, let me now again take the help from calculator, 7.5 multiplied by 7.5 multiplied by 1.73, so that's like 97.31. 97.31 square centimeter. So this is what we have got, the value of the area of the triangle, right? Now let's get back to our original question, and for this we were looking at the area of the sector OAPB, which we have got here, and the area of the triangle is this, right? So let's put these values into this, and we will get the answer here. So area of the minor segment, that's equal to the area of this sector, which is 117.5 minus 97.31. So that's equal to 117.5 minus 97.31. So that's like 20.19 square meter, right? So that's the final answer. So I hope you guys could understand this and you enjoyed watching this video, and I am coming up with more videos of circles. Keep watching these videos and keep sharing these videos. Thank you so much. Have a nice day. Bye bye.